Let's work through the concept of derivatives. Let's understand what is first order, second order derivative, stationary points and inflection points. And let's do this all on a graph. We'll probably make 2 videos on it. X, Y. And let's say this would be the graph. Let's draw it something like that. So here and there. Okay, so first things first, what is the first order derivative? The first order derivative shows us the rate of change between y and x. Now, if the first order derivative is positive, it means the rate of change between y and x is positive. What is the rate of change between y and x? That's a slope. It means when x increases, y increases as well. And if x increases and y is increasing as well, that literally means that the function is increasing. We're getting higher and higher values for y. And let's see how that looks like here. If we have this x value and then we increment x value until here, let's say x plus h. Well, the function, we could see that we had f of x over here, but now we have a bit of a higher value, f of x plus h. So the function went up, and visually we can see that it's indeed getting higher and higher y values as we increment x along the way. Now, what if the opposite happens? What if the first derivative is negative? Well, that means that the rate of change between y and x is negative. And how that look like? Well, let's suppose the function would start falling. We can see that from this point, from this x value, moving to the next x value, so another x plus h, the function goes from this point on the graph over here, so the function is literally decreasing, and indeed the slope is going down. This would be the slope of the point on the graph, and it's sloping downwards, so the function would be decreasing. That's what the first order derivative shows us. Now let's look at the second order derivatives to understand. Well, the second order derivative shows the behavior of the first order derivative. I hope this will make sense. So, second order derivative. Let's write it here. That is literally the first order derivative differentiated once again. And we again have 2 cases. What if it's positive, and what if the second order derivative is negative? Well, let's see. If the second order derivative is positive, that means that the rate of change of the function is changing at a positive rate. So the rate of change is increasing. In this case, when the function is going up, that's the first order derivative, and that's positive. Now the second order derivative of this function shows how is the function going up. Is it going up at an increasing rate or at a decreasing rate? And visually we can see that the slope is becoming from flat to steeper and steeper and steeper and steeper and steeper. So the slope is increasing of the function, which means that the function is increasing at an increasing rate, and we call this shape as a convex function. So when the second order derivative is positive, we have a convex shape. Now let's have a look over here. What is the second order derivative when it's negative? That's the first order derivative. That's the rate of change of the function decreasing. So we are changing our function at a decreasing rate. Let's have a look over here. Look what happens from this point onwards. The function is steep, right? The slope is steep, I'm sorry. But then look what happens. It flattens, it flattens, it flattens, and it almost, it actually reaches the peak where it's completely flat. So the slope itself is decreasing. It becomes from steep to less steep, and flat. So the function is increasing here at a decreasing rate. The derivative, the rate of change of the function is decreasing. So we have a concave shape. That's how we note it. Convex and concave. I hope this makes sense. In the next video we'll go through the concept of stationary points and inflection points.